All right. My name is Jonas and I run strategic partnerships for PubNub. First off, I want to thank the Qt team for inviting us here. It's a pleasure to be here. Before I get started, just a heads up, I'm going to spend a few minutes talking about our business before introducing my colleague, Jordan Zucker, who's going to talk through a connected car demo involving Qt, PubNub, and our demo partner, the Ford Motor Company. Thank you, Brett. So with that said, show of hands, how many people are familiar with PubNub? All right, 2 out of the entire group. We're going to fix that right now. Okay, our mission is to securely connect every device on the planet in less than a quarter of a second. And that equates to the human perception barrier for what is considered real time. On top of that, we also share a number of common goals with Qt, whereby we try to speed development time for each of you out there, enable compelling new features, and of course work cross-platform. That said, PubNub is a data stream network. Our entire focus is on the high-speed, reliable, and secure delivery of two-way communications across any number of connected devices worldwide, from mobile and desktop to server and embedded. Now, when we talk about two-way communications, we're really talking about data in motion, like the location of a vehicle, the status of a device, on out to the nuts and bolts of secure two-way chat. So infrastructure-wise, we built our business very much like that of a CDN, whereby we intelligently cache and stream data to devices from 14 fully replicated points of presence all around the world. We also make it very easy for developers to hook into the network with just a few lines of code. And then we do all the heavy lifting automatically behind the scenes. Network protocols, device support, real-time features, on out to the host of things you'd have to deal with deployment and scaling. In fact, we're currently working with about 2,000 customers around the world today. We have billings in 75 markets and use cases in some 50 or more verticals. Transportation, healthcare, financial services, entertainment, you name it, we're in it. Under transportation, we pretty much own the connected taxi space. So while we don't power Uber, we pretty much power all of their competitors for real-time dispatch and location tracking. So Lyft, Sidecar, Easy Taxi, Get Taxi, Zoomy, Curb, all use PubNub. Under smart home, we don't power Nest, although we do power pretty much all of their competitors. So Insteon, Vivint, Logitech, Wink, as well as iControl with their Piper brand, all use PubNub to securely monitor and control devices behind a firewall. Stats-wise, we are currently touching around 300 million devices a month, and this month we'll transact about 1 trillion messages. Just massive, massive, massive scale, all with quarter-second latencies and 5.9 SLAs. That said, PubNub is indeed easy to use for developers. All of our SDKs are available to trial for free on our website, including a brand new SDK for Qt, which we've been racing to finish, and it's almost done. I've been told it's going to be ready in 2 days. So please go to pubnub.com/Qt to sign up, and you'll be notified in 2 days of how to get access to our new Qt SDK. So with that said, I'm going to introduce my colleague Jordan for a connected car demo.
Hi, I'm Jordan. I'm a client SDK engineer at PubNub, and I'm here to tell you a little bit about some stuff. So let's start with what we already know. So data in motion is a pretty new concept. Sorry, hold on 1 second. Perfect, okay. So data in motion is a pretty new and up-and-coming field. There's no real reliable and mature standards, and there's a lot of security risks, and some of these are already starting to come to light. We have more reliable connectivity, sorry. All of our messages are time-stamped within 10 nanoseconds on our network. So we can bring some reliability back to this data in motion. If we miss messages, if we go through a tunnel and you come out the other side, we can gzip and bring you all those messages that you missed, and all the timestamps will allow us to recreate that for you. At our core, our base feature is PubSub, publish, subscribe. So we use a variety of techniques to keep this power efficient and low bandwidth. We open sockets to these devices, and we hide all the complexity behind a single line of code. PubNub.publish. This is basically the same pattern we have on all of our SDKs, and you can publish from one-to-one or one-to-many. And then we have on the reverse side of that, PubNub.subscribe. All you have to do is choose which channels you want to subscribe to. And as we mentioned before, the same paradigm is supported on over 70 SDKs. To be clear, we don't do request response like data and REST. which keeps ports open. This is a massive security risk. Instead, we do only an outbound connection. So if a hacker's scanning, they won't even know the device is there. So now that we have a secure and persistent socket connection open to the device, we're able to provide other valuable services. We call these building blocks. Presence detection allows us to auto-connect when device status changes or it disconnects or reconnects. We get storage and playback, which allows you to store real-time data for any length of time you can imagine, to infinity, with the ability to do history calls for retrieval of messages across any time period. You can even replay messages in the order and time as they were originally sent. And we have a stream controller. This allows you to subscribe to thousands of channels on a single socket. There's also an access control layer built on top of that, which allows for security and syndication purposes. We have a mobile push. This allows you to deliver push notifications to iOS or Android in the case of the app going offline or going into the background. This ensures message delivery even when that socket isn't open. We'd be happy to go into these in more detail if you visit our booth upstairs on the first floor, but let's proceed with the demo for now. So, everyone, if you'd like, and you'd like to participate in this demo, and please do, go to this website right now. Seriously, please open your phones or your computer. So, to give you a little background about this demo, we have a forward sync TDK, and I built an iPhone app to connect to it, which is right here. It doesn't have much of an UI, because right now we're actually simulating a drive, and we're outputting data. And the cool thing about this is we have a Qt app over here. For all of you who would like a little proof, here's the iPad app that it's connected to. So this is streaming data. Now, it might look like they're right next to each other and they're talking directly to each other, but in fact, they're talking. This app talks to PubNub in the cloud and our servers all over the world, 14 different data centers with less than a quarter-second latency, and then it pulls down from this Qt app to update these gauges right over here. So the demo looks pretty easy, but there are actually quite a few challenges on the back end. PubNub saves you time from writing all that low-level socket code. You don't have to learn all of the networking frameworks in Qt. You don't have to learn the networking frameworks on iOS. You don't have to learn them on the platform you choose to do on. Instead, you could spend your time writing nice animated GUIs, just like this, which was actually very quick and easy to do. With our SDKs, I was able to get this demo together in a matter of days, whereas it would have taken me weeks to learn socket code on any of these platforms. Yeah, it was actually literally this all came together in a week. So here's our technology stack for all the various parts involved. We have two basic aspects to this. There's a publisher, which is this end of the room, and we have subscriber, which is this end of the room. So it might look like there's a lot in here, but really all of these connect in a very straightforward manner. And PubNub is the glue that holds these two sides together. And technically, if any of you went to the site, then you're also a subscriber. And that technology stack is not represented, but it's pretty straightforward. It's just JavaScript. So on the publisher end of things, we have the forward sync TDK, and that talks to the Smart Device Link API, which is written in iOS, and that talks to our PubNub iOS SDK, which pushes data out to our PubNub data stream. So the PubNub, and by the way, this all works in Swift and iOS, and on iOS 9. So this might sound complicated, but it's very easy to publish in PubNub. As you can see up here, it's one line of code to initialize a PubNub client instance. And this is, if any of you are familiar with iOS, this is a basic init method for a class. And then one line to publish. If you noticed, you supply a pub key, a publish key. You don't need to supply a sub key in this case, a subscribe key. I provide a dictionary in the bottom to publish. It's automatically converted to JSON, which is recognized on every platform. Talk to me afterwards if you'd like a Swift example. It's very easy to do. So the PubNub C++ SDK, we have the PubNub Data Stream Network on the subscribe side. And this talks to the PubNub C++ Qt SDK, the one that Jonas just mentioned. We actually have working versions of it, and we'll be releasing it very soon. And this talks to the Qt C++ native framework, which then renders awesome gauges in the Qt QML JavaScript framework. The Qt JavaScript framework is very easy to work with. There's very fast animations. The subscribe code on this end is very straightforward. It's a very simple subscribe loop. We have 3 lines of code to get this working. All we're really doing is creating a subscribe instance and then connecting the signal coming from the subscribe data to the slot on subscribe, which is our callback. And then the last line, we include the channel we're subscribing to. So let's take a look at that on subscribe slot. It looks a little complicated, but really there's a line at the top to handle errors and a line at the bottom to resubscribe. This is C++, so you have to take a little extra step yourself. But really the bulk of this is just parsing JSON and then updating values. I created a separate value source object in this to abstract away the GUI from the model. But really this is very straightforward.
I wanted to make one point clear. I know we were stumbling with our keynote, but I apologize for that. So you saw how PubNub connects devices in a quarter second or less. We do that using our data stream network, which we talked about. We also can survive very unreliable connectivity environments, which is important in the connected car space and more. Anything can happen in the wild. You can go from 2G, 3G, 4G, in and out of tunnels. So the way we work in PubNub is when you establish that secure outbound socket connection and push data back to the device, to me, that's a persistent dial tone to the device. That's a good way to think of PubNub. Now, that device is always on. It's always communicating to PubNub. If it goes into a tunnel, for example, in the connected car world, as soon as it pops out, we reestablish a connection. And if that device has missed anything, we catch up to the closest 10 nanoseconds. And that's an important thing to point out where PubNub is concerned. So I'm gonna summarize without oh, good, we have it here. Thank you. You want to do it, or should I? All right, well, I'll just run it through. So what you just saw here was PubNub working in the connected car space. We showed you how we provide very reliable, highly reliable two-way communications across any number of connected devices globally. We've also talked about security at a very high level. And I will tell you that our security approach involves really 4 key tenets. So it's a combination of absolutely no open ports, even on the server side. And everything we do involves a secure outbound socket connection, absolutely no inbound ports. We also use encryption. Off the rack, we provide AES and TLS encryption. You can also bring your own. We never hold the keys you do. So, you know, and I live in the States, so if we get subpoenaed by the NSA for data, we can never give them anything. We don't have the data. It's all encrypted. We also use fine-grained access controls, and we have a whole legislative layer too. So if you need to keep data within the EU for safe harbor purposes, you can certainly do that. We can intelligently route data through our network. Very power efficient. Our PubSub involves less power than Google's own GCM. So I think we've said that we can, you know, with very low joules allocated on the car side, we can probably keep a secure connection open with a car that's turned off for probably 30 or 40 days without killing the battery. Low bandwidth, we talked about that for a bit, and also scalable. 14 points of presence, and it's exciting to be here. Anything else we should bring up now? I think that's kind of it, but please, I know we just gave you guys a quick tour of PubNub. Visit us upstairs, we're on the first floor. We'd love to talk to you about our business, and we're very excited to be here with Qt and, of course, Ford. So that's it. Any questions? Someone has to have a question.
Globally. Do I need to repeat? Yeah? So
Yes.
Can you provide the latency also globally? For example, if some user is in China inside the firewall and then others are, let's say, in US, and you can still provide the speed within your system?
The answer is yes. We have 14 points of presence on 4 different continents. And actually, if you're within 1,000 kilometers of one of our data centers, we're seeing somewhere between 20 and 30 milliseconds round trip from publish to subscribe. We do not have a data center in China yet. I'll leave that open.
We also, all the data centers are self-replicating, so if there's an issue on any one of them, it's easy failover to any of the other ones.
Did you consider to use something else than JSON, like Google protocol buffers or so?
Say it one more time.
Did you consider to use something else than JSON?
Oh,
for example,
yes.
Google protocol buffers. JSON is not really cheap to parse, especially when you get everything right.
Yes.
And error detection and so on.
Yes. When you're making a demo, JSON's great for that. When you're scaling a much bigger application, there are other ways to go about this, and we can talk later on a more technical level about different solutions to that, but yes, that is definitely a possibility.
I imagine that once in a while at 0.25 seconds latency, you will have dropouts because internet simply cannot guarantee this. What are the dropout rates there?
That's a good question. I mean, obviously we can't guarantee the last mile, and we can't guarantee that you have internet connection. So when we're saying 20 to 30 milliseconds, you know, we're looking at the lowest common denominator, 2G, 3G, when we're pretty good. Does that answer your question? Yeah.
We also do have catch-up. So if you do drop out, when you do reconnect, like going through the tunnel or switching from 3G to 2G, we'll catch you up on the messages you missed. Not exactly the solution you're looking for, but we do kind of try to cover. We can't do anything if you're not connecting to a cell phone tower. We can't solve that problem. Yeah.
Another question.
Mm-hmm. Sure.
You mentioned that you use AES. I think it's some block cipher using with AES. That's pretty known to be safe, even from the NSA. That's not an issue. But actually, history shows that not data is important, but metadata. What about the metadata you are collecting?
Yeah, I mean, what I would say with the metadata is that we can put a wrapper around the packets. I mean, just so you know, a payload for us is about 32K. And we haven't officially announced it yet, but we are going to start doing more computation at the edge, and a lot of that will involve the metadata on the actual envelope. So it's a side answer to your question, but we do use that, and it's purely for routing. It's doing smart things with the data streams. You know, it's not anything more than that.
We have some back-end engineers who would probably love to talk to you about this too. I'm a client guy.
All right, thank you, you two. With that.